Okay, in this video, I'm going to attempt to solve the integral of du divided by u squared minus a squared using the method of partial fractions. And we had an introduction video to this, and we see it should meet the requirements to being solved with this technique. We just have a 1 up here in the numerator, so obviously that's of lesser degree than what's down here in the denominator, and the denominator can certainly be readily factored. So let's see what we can get out of this. We'll have 1 over u squared minus a squared, and we can factor that. We have u plus a times u minus a, and we have two linear terms to the first power, so this would just be some constant over u plus a, call that constant e, plus another constant over u minus a, we'll call that constant f, and we just multiply through, and we have 1 will equal e times u minus a plus f times u plus a. And if you multiply through and collect terms, it looks like we have 1 will equal u times e plus f, and we will have f minus e times a. Okay, and on this side of the equation, we don't have any u terms, so e plus f is going to have to be 0. Our constant term here is 1, so f times e minus a is going to have to equal 1. So let's write this down. E plus f has to be 0, so we can say e that equals minus f. And from here we have f minus e times a equals 1. It has to equal 1. And e is minus f, so we have 2f times a equals 1. So f will equal 1 over 2a, and e is the opposite sign of that, so e equals minus 1. Oops. E is minus f, so e is minus 1 over 2a. So we have this 1 over u squared minus a squared, and f is 1 over 2a, e is minus 1 over 2a, so taking the positive term first, we have 1 over 2a this is the f term here, and then e is minus, so have minus 1 over 2a times u plus a. Alright, so our integral then of du over u squared minus a squared, we broke up into two integrals. We have 1 over 2a du divided by u minus a minus 1 over 2a, integral of du divided by u plus a. And we should recognize these integrals now. This would just be the natural log of u minus a. This would be the natural log of u plus a. So we have 1 over 2a minus 1 over 2a times the natural log of u plus a. And you can throw in an arbitrary constant. That would be the solution then to this integral. And because these are logarithms, we can rewrite it if we want as 1 over 2a, the natural log of u minus a, divided by u plus a, plus an arbitrary constant. And that over u squared minus a squared. So that was pretty straightforward application here. We'll get to some more complicated examples in the next videos coming up. One thing further we could say about this integral, though, if you remember from the integrals where we dealt with trig substitution, here we have a variable squared minus a constant squared. So we should be able to solve this integral not only with partial fractions, but with a trig substitution. Let's do that in the next video. We'll tackle this not using partial fractions, but with a trig substitution, and let's see if we get the same answer as we got using partial fractions. So come join us for the next video, and let's see what happens.